Welcome to Hartman Math. Today we're going to talk about analyzing graphs of functions. Before we get there, let's go ahead and pause the video here as you work through warm-up problems 1, 2, and 3, and resume when you're ready. All right, number 1, we're doing g of n minus 3, which goes right there. So we're going to get 3 minus the square root of n minus 1. For number 2, we've got h of negative 4, where negative 4 fits the condition here in less than or equal to negative 2. So that's going to be it's 18. H of negative 2 also fits that condition. So we get 6. And then h of 10, 10 being greater than negative 2, we're going to get negative 5 there. And some practice with the difference quotient. You should have gotten 2x plus h, where h cannot equal 0. This is lesson 1.5, analyzing graphs of functions, taking a look at a function and its graph. Can we come up with domain, range, and some function values? Typically, we're going to use interval notation. So if you're doing anything with WebAssign, make sure we've got the correct notation, parentheses, brackets, and so on. The domain is all the possible x's, thinking how far left and how far right. So we're going to start at negative 1. We're going to finish at 6, but with an open point there being a parenthesis here, but a bracket since it's a closed point, the negative 1. Range is up and down. Start low. So always go lowest to highest there, least to greatest. So the y-coordinate negative 5, the highest y-coordinate right there occurs at 3, and there is a point there, so it's going to be a bracket. F of negative 1, when x is negative 1, f of really means y, so the y-coordinate is negative 5. F of 4 is 3. F of 6 is not 2. It's an open point. 6 is not in the domain, so that would be undefined. There is no value there. All right, checkpoint. Looking at the function f of x equals the square root of x minus 4. Come up with domain and range. It might help if you sketched it first. Pause, come back. We're talking about a square root function that has been translated right 4. So the domain, bracket 4 comma infinity. The range starts at 0 and goes up, 0 to infinity. If we're trying to determine if, based on the graph, if a relation is a function, we perform the vertical line test, passing a vertical line across the graph itself. If it never hits more than one point at any time, we're good, and it's going to be a function. To find zeros of the function, that occurs when the function has x-intercepts. Zeros are just numbers. X-intercepts are points. So zeros are just the value of which, when we plug it in, we get an answer of 0. Example number 3, find the zeros of the function. So to find the zeros, we could just set it equal to 0, solve. It's quadratic. We could try factoring, maybe the quadratic formula. Go ahead and set it equal to 0. We might be able to factor this one. And then use the zero product property. 3x plus 7 equals 0. X minus 1 equals 0. Solve for x. With x equals negative 7/3 or x equals positive 1. Those are the zeros of the function. All right, checkpoint. Go ahead and find the zeros of g of x. Pause here. Resume shortly. All right. In terms of this being a rational function, being a fraction, zeros come from the numerator. not come from the denominator, they come from the numerator. Okay, so if we set the whole function equal to 0, we could multiply fraction bus, multiply both sides by x plus 5 to get to here. Or knowing that they come from the numerator, we could have possibly just started right there also. It then becomes a square root method problem. Add 7 to both sides, square root, don't forget the plus or minus. Probably box that answer right there. Those are your zeros. Next thing we're going to analyze about the graphs of functions is where are the functions increasing, where are they decreasing, where might they be constant. So here is the definition. When x1 is less than x2, if that implies that f of x1 is less than f of x2, we've got an increasing. That is a really complicated thing to understand, especially at this time. So we're really not going to use this definition, although it's true. We're not going to use these definitions. We're really going to more analyze what the graph looks like to be able to determine where is it increasing, decreasing, and constant. So, as an example, we've got kind of part of a function or a function listed here. It is decreasing. And then when you're analyzing increasing, decreasing, and constant, you must travel along the graph, always moving from left to right. You can't look at it this way. It has to be from left to right. If it's going down, we're saying it's decreasing. If it's flat or horizontal, it's constant. If it's going up, it's increasing. You have to be looking at it going from left to right. And when we answer, we're always going to answer in domain intervals, x coordinates only, from -2 to 0, from 0 to 2, from 2 to 4. And then also when we do that, we're always going to use open intervals, which means parentheses, because at this point it's doing nothing. After that point is where it's decreasing. Here it's changing. So at 0 we would not use a bracket. It's not decreasing, it's not constant. It's changing between the two. So we're always going to use open intervals. They're always domain intervals, x coordinates only. So we're looking at a function f of x, pretty complicated function, but we can see its graph. Where is it increasing? Where is it going up? So it's increasing here from -6 to -4, x coordinates only. Where is it decreasing? Well, it goes down, 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 starting at -4, and then notice that there's no point there, so it's really indicating it's going to keep going. So from -4 to infinity. There's no place where it's constant, so we could put none. All right, checkpoint, look at the function. Where is it increasing? Where is it decreasing? Where is it constant? Go. All right, increasing. Again, you have to look at it from left to right. Going up. Here's where it's flat from 0 to 4. Constant. Decreasing, going down over here from 4 to infinity. Always look from left to right. Relative minimums and maximums. Again, we've got complicated algebraic definitions. If you want to read through, great. But what we're really saying is that there is a relative minimum if it was decreasing and then it changes to increasing. That's where there's going to be a relative minimum. It was decreasing, it changes to increasing. Where it made that change, there is a relative minimum. Conversely, the other way around, if it was increasing and then changes to decreasing, that's where there's going to be a relative maximum. Example number 5, approximating. Use a graphing utility to approximate where that's going to happen. So we're going to need to use a graphing calculator and type in that function f of x equals x cubed minus 2x squared. Let's go over to the graphing calculator, input that, see what it looks like. All right, so we're going to press y equals first. Our function was x, and then use the up caret raised to the third power, arrow to the right to get out of the exponent, minus 2x, and then I can press squared, or I can use the up caret again. But there's my function. Let's check our window. Press window. Make sure we're standard. If you had done something before, change it back to -10 to 10 by 1s, -10 to 10 by 1s. If you are using a Texas Instrument, be very careful. If you put subtraction here instead of negative sign, as those are two different buttons, it's going to give you some sort of a window error message. So that's what to watch out for. So let's go ahead and graph this and see if we then need to adjust our window. Press graph. Okay, not too bad. If we wanted to kind of narrow down on this, we could definitely not need to go all the way out to -10 and 10 on the x's, kind of shrink it in, and we could probably, if we want to really investigate what's going on here, probably don't even need to go as high. So let's adjust our window. -5 to 5 by 1s. And we could even do the same thing here, -5 to 5 by 1s. Press graph again. Now we've got a better idea of what's going on. Again, we can trace, but that's informal. It's not going to give you formal answers. So where we get the formal answers is calculate. Press calculate. So second trace. And as you can see, a couple of our options is minimum and maximum. So that's where we want to go. If we want to look for a minimum, let's go there first. Number 3. Now it's going to ask you for a left bound. So remember, our minimum is going to occur when it was going down and then changes to going up. When it says left bound, it basically needs to know where should it start, where should you want to tell the calculator to start looking. So we need to make sure we are left of where we think the minimum is. And this is fine, or you can get a little closer and then hit enter. Enter. Then it's going to ask for right bound. So it's basically saying where should it stop looking. So we're going to arrow to the right until we are safely to the right of where we think that minimum is going to occur. It's going to ask, do you want to make a guess? And you can see here with these arrows, that's where it's going to look. And I don't think we need to make a guess. So just hit enter. So the minimum occurs at when x is 1.33323 and the y is this. Make note of that for our minimum. I don't think I see any other place where it was going down and going up. So now as far as maximum, we'll redo the problem and then we're going to look here. So second trace to calculate. Let's find a maximum. We need to be left of where we think it is. That should be safe. I hit enter. Arrow to the right to get to the right of where we think that maximum is. Hit enter. And I don't have a guess, so I press enter. And we got to be smarter than the calculator. When it says 1.3256 e -6, it means times 10 to the -6. Or slide the decimal 6 places to the left. 1, 2, 3. So really, it's a very, very small number. We're really basically saying that this is 0. And the same thing here, that's essentially saying 0. So we kind of got to outsmart the calculator. 0, 0 is where that's happening. So our graph ended up looking like this. If we did this on Desmos, nice thing about Desmos is you just tap there and there. The disadvantage to Desmos is if you were taking like an SAT test, you're not going to be able to use Desmos, whereas you could use a graphing calculator. If you're taking AP calculus, same thing. All right, so we've got minimum. We didn't have to find the maximum, we just find the minimum. Where is it increasing, decreasing, and constant? Increasing here. X is only increasing here. x's only. And then decreasing right here. So parentheses, x coordinates only. All right, next thing about functions is whether they might be odd or even or neither. So the definition, algebraically, the function is even when we try f of negative x, and it comes out to be the same thing as the original function f of x. That's going to be an even function. If we start out with f of negative x, and we get the opposite of f of x, that's going to be an odd function. So as you can see algebraically, here's always your start. Try f of negative x and see what you get. In terms of graphs, even, those are going to have a specific type of symmetry. The graph will be symmetric about the y-axis. Odd functions have different kind of symmetry. They have point symmetry about the origin, meaning if you spin the graph halfway around 180 degrees, if it looks exactly the same as it did to start, that's going to be an odd function. But let's look at it algebraically. Here's the graphs. So even, symmetric about the y-axis. Odd, if we spin it, it's going to look the same, symmetric about the origin. Now, algebraically, can we determine what the function is, even, odd, or neither? Again, we always start with f of negative x, show the substitution. And we're just kind of work it out and simplify. We're going to look for first, does it come out to be the original function? If not, we'll adjust from there. So 3 times negative x, negative 3x. When we cube a negative, we're going to get a negative. So we're getting here. Now, is that the original function? It's not. Okay? If it was, we would say equals f of x, but it's not. So the next thing we're going to check for is odd. If we're checking for odd, we want to see if it's the opposite of the original function. So we have to factor out the negative. So that is your next step. If you're checking for odd, factor out a negative. Even if you don't see it there, factor out a negative. So we'll do that. We'll factor out a negative. What is this? That is f of x. So we'll say this is equal to negative f of x. You absolutely have to have this step. If you skip and stop right here and then say it's odd, you will not get full credit because you've not used the full definition. We started here, we arrived at this conclusion, that defines us to be, this function to be odd. You have to have all those steps. None of them are skippable. Okay? Must have that step there. All right. Checkpoint, got an A and a B. Check to see if they're even, odd, or neither. Pause the video here. Resume when you're done. All right, part A, g of x. I think this one's going to be a neither. We can give it a try. We can simplify. It's not the original function. We could factor out a negative. That's not the original function, so it's not the opposite of the original. We check for even, we check for odd. Neither worked. It is a neither situation. About part B, h of x. Well, h of negative x. When we square negative, we're going to get a positive. That is the original function. So we say it's the original function. Started here, concluded there. That's the evidence for even. All right, this is our last one to look at. We've got a function here. Y is equal to 4x minus x squared. And we're looking for within this part of it, the height of this rectangle that's created here. So the height of the rectangle is always going to be the top curve minus the bottom curve. Now in this case, the bottom curve is a line. We just kind of generically default to saying curve. So top curve minus bottom curve. Be careful, because if we were to extend this, and if this kept going and that kept going, in this area over here, this is no longer the top. Over here, this is the top, and this is the bottom. But right now, we have top minus bottom. Now, what is the bottom? We've got the top, it's easy right here. But the bottom is the horizontal line that passes through 3. Hopefully we know that that's just y equals 3. So the height is top minus bottom. Our top function for this part of it is 4x minus x squared. Subtract the bottom function, which was the horizontal line, y equals 3. So clean that up. There's our function. But as we said before, that's not true everywhere. You have to give the domain for that function. It's true from 1 to 3. From here to here, that was the top and that was the bottom. So that's the height only from here to here. If you don't have the domain, you don't have it. So you have to also put the domain in. That is true on this particular domain. That's it for today. We'll see you next time.